The first question that's going to be answered is as follows. A football player throws a football with initial vertical velocity of 68 feet per second at a height of 6.2 feet above the ground. Determine the maximum height attained by the football at the time required for the football to hit the ground. The formula that's needed to solve this question is f of x is equal to 1/2 gt squared plus v sub 0 t plus h sub 0, where g is equal to the force of gravity, or 32, t is equal to time, v sub 0 is the initial velocity of the object, and h sub 0 is the initial height. And so all I did was take the values that were given to me in the question and plug them in to get the formula. So the formula is f of x is equal to negative 16t squared plus 68t plus 6.2. Next, using the vertex formula, which is negative b over 2a, I plugged in the values from the formula, and that got me at what time the ball will reach the maximum height, which is also the x value. And so at 2.125 seconds, the ball will reach its maximum height, so I plugged that 2.125 back into the equation to get the maximum height of the ball to be 78.45 feet. The last thing I did to answer this question was found the time it took for the ball to hit the ground. And the way that I did that is I set the formula equal to 0, because when the ball's at the ground, the height will be 0. And then the easiest way to solve this is I plugged in the values in the formula to the quadratic equation. So I got negative 68 plus or minus the square root of 68 squared minus 4 times negative 16 times 6.2, and then all of that divided by 2 times negative 16. And the x values that I got for that was negative 0.089 and then 4.34. And negative 0.89 seconds doesn't work for this in this situation because you can't have negative time. So the only answer that would work is 4.34. So it took 4.34 seconds to hit the ground. The second question kind of piggybacks on the first one. And the second question is, on the same throw, the player throws a football with an initial horizontal velocity of 64 feet per second. Determine the horizontal distance traveled by the football. Then write a set of parametric equations that describes the path of the football in terms of the parameter t, which represents time. The way that I solved the first part of this problem was, since I knew that the horizontal velocity was 64 feet per second, and the equation for the distance is distance is equal to the rate times the time, I knew that the distance would equal 64, which is the rate, times the time, which is 4.34 seconds, which was found in the previous question, because that's how long it takes for the ball to hit the ground. So we know that after multiplying those out, we know that the ball traveled 277.76 feet. So the last step to this question is to find the parametric equations that will result in the horizontal and the vertical distances. And parametric equations are a set of equations where whatever value you plug in for t, it will result in the x and the y value that you want, so the horizontal and the vertical distance. So the parametric equation for this question is x is equal to 64t and y is equal to negative 16t squared plus 68t plus 6.2. And those are just the equations that were found in the previous two questions. And so basically what this says is whatever value I plug in for t for time, it will give me the horizontal distance and the vertical distance at that time.